The word planet sounds simple. A big, round world. A sky. Maybe weather. Maybe oceans. Maybe a sun somewhere nearby. But that picture starts falling apart the second we look beyond our own neighborhood. Because out there, we've now found planets with no sun at all. Planets so hot they outcook some stars. Planets where metal may condense out of the atmosphere like weather. And planets that are not even stable worlds anymore, but objects actively coming apart in real time. So, the strangest thing about exoplanets is not that a few of them are weird, it's that the word planet may be a lot less simple than we thought. For most of human history, we learned what a planet was from exactly one sample, our own solar system. Rocky inner worlds, gas giants farther out, reasonably clean orbits, one star in the middle. A setup so familiar that it still feels like the default version of reality. And emotionally, it still is. But astronomy has a way of humiliating whatever we first decide is normal. NASA's running count of confirmed exoplanets has now climbed past 6,000. And the more that number grows, the harder it is to pretend our local setup is the rulebook. Take the first rule most people never even think to question. A planet orbits a star. That feels so basic it barely sounds like a rule at all. Except some planets don't. They drift alone. These are rogue planets, worlds that are not bound to any nearby star. No sunrise, no warm parent sun in the sky, no bright daytime at all. Just a planet wandering through interstellar darkness, carrying whatever heat it still has, or whatever heat its interior can still generate, while the rest of the galaxy hangs around it like a distant frozen backdrop. If you stood on one, the weirdest thing would not be what you saw. It would be what never happened. Morning would never come. That idea sounds almost fake, but astronomers have been building better and better ways to look for worlds exactly like these. One of the most powerful is microlensing, which, in plain English, means using gravity like a temporary magnifying glass. If a dark object passes in just the right place, its gravity can briefly brighten the background starlight behind it. Not because the object glows, but because gravity bends the light. So, even a world that gives off no sunlight of its own can still betray itself for a moment, like a ghost crossing a flashlight beam. That is one reason NASA's Nancy Grace Roman Space Telescope matters so much. Roman is designed to watch huge star fields with the sensitivity needed to catch many more of these brief microlensing events, which means the coming years could tell us just how crowded the galaxy really is, with worlds that have been thrown out of their birth systems and left to wander alone. And already, that should be enough to break the clean textbook picture. Because if a planet can exist with no star at all, then planet is already a broader, stranger category than the one most of us carry around in our heads. But rogue planets only break the first rule. The next worlds break your senses. WASP 7-6b is one of the most famous exoplanets ever found. Not because it looks dramatic from far away, but because once astronomers studied its atmosphere, the picture that emerged sounded like pure science fiction. This is an ultra-hot giant world, tidally locked, with one face always turned toward its star. On the day side, temperatures climb above 2,400 degrees Celsius, hot enough to vaporize metals. Observations with the European Southern Observatory's Very Large Telescope found iron signatures in its atmosphere, and the leading interpretation is wild. Powerful winds may carry iron vapor from the blistering day side toward the cooler night side, where it can condense into droplets. In other words, under this model, it may rain iron there. That phrase is so good it almost sounds dangerous, because it makes you picture a rocky planet with metallic storms slamming into the ground. But that is not what makes this world so strange. The real shock is more fundamental than that. Weather, one of the most familiar things in human life, stops behaving like something your brain evolved to understand. On Earth, weather means water cycles, clouds, rain, snow, wind you can imagine standing in. On WASP 7-6b, the idea of weather gets dragged into a chemistry lab inside a furnace. If you could somehow hover near the boundary between permanent day and permanent night, you would be looking at a world where the atmosphere itself may be sorting metals out of heat, not blue sky and white clouds. Not anything remotely home-like, just an environment so extreme that even the word rain has to be borrowed and stretched until it barely still fits. And that is the moment the video gets bigger. Because at first, these sound like fun exceptions, weird one-offs, monster planets. But the more of them you line up, the less this feels like a collection of curiosities, and the more it feels like a warning. Maybe the problem is not that a handful of planets are bizarre. Maybe the problem is that we learned the word planet from one tiny, emotionally biased sample and mistook that sample for the cosmic norm. Because if you still think planets are basically cooler, calmer objects orbiting brighter, hotter stars, then Kelt 9b comes along and crushes that too. Kelt 9b is a gas giant in an absurdly tight orbit around a blazing blue star. Its dayside temperature is around 4,600 Kelvin, hotter than most stars, not most sun-like stars of course, but hotter than many smaller, cooler stars, including ordinary red dwarfs. NASA described it exactly that way, a planet hotter than most stars, and the star it orbits is so intense that it is likely unraveling the planet through evaporation. Just stop on that for a second. A planet hotter than stars. That sounds backwards in a way the brain does not like. We think star means heat source. Planet means cooler object nearby. Big, bright thing. Smaller, darker thing. Kelt 9b keeps the second part and destroys the first. If Earth were moved anywhere near that system, this would not be a climate problem. This would not be an extreme weather problem. This would be a complete materials problem. Molecules get ripped apart there. Atmospheres do not merely circulate there. They boil away. This is not a destination. It is a world losing an argument with its own star. And even that still leaves one comforting assumption alive. At least a planet is still a finished object. A stable world. A completed thing. Except sometimes it isn't. Sometimes what we call a planet is really a temporary event. A recent example is BD plus 054868. AB, a world discovered in test data that appears to be disintegrating. What made astronomers notice? It was not a neat, ordinary transit. It was a messy one. The dips in starlight changed. The shape looked asymmetric. And the best explanation was dramatic. Dusty material was streaming away from the planet in comet-like tails. Not just one tail, but evidence for both leading and trailing tails. NASA's catalog lists the object as a Neptune-like exoplanet discovered in 2025, and the discovery paper describes it as a disintegrating rocky planet with prominent comet-like tails. That is such a different texture of reality than the one most people imagine when they hear the word planet. Not a world waiting to be mapped. A world in the act of shedding itself into space. If you watched it from nearby, you would not be seeing the calm silhouette of a planet crossing its star. You would be seeing a body being abraded into a stream of dust, a planet behaving less like a place and more like a wound. And suddenly, the category changes again. A planet is not always a finished environment. Sometimes it is an unstable process with a countdown attached. At this point, the weirdest thing is no longer any individual exoplanet. It is how stubbornly our own mental picture tries to survive them. Because once we accept starless planets, metal weather planets, star-hot planets, and disintegrating planets, one thing becomes hard to ignore. The solar system did not teach us what planets are. It taught us one local accent of planet making, and there may be many others. One of the strangest newer hints of that comes from a system called 2M1510. This one is interesting because the central objects are a pair of brown dwarfs, bodies too small to sustain hydrogen fusion the way ordinary stars do. And around that pair, researchers reported strong evidence for a planet in a polar orbit. That means instead of orbiting around the binary in the same flat plane you might expect, the planet appears to go around at roughly a right angle to it. The easiest way to picture it is a racetrack. Now imagine every car circles flat around the track, except one that somehow drives around the stadium vertically. That is the kind of geometry we are talking about. Even if most viewers never memorize the system name, the meaning lands instantly. Stable does not have to mean familiar. A planetary system does not have to copy the layout that made sense to us first. And if you stood on a world in a setup like that, the sky would not feel a bit different. It would feel wrong in the most fascinating possible way. Not because physics had failed, but because physics had worked perfectly well and built something your intuition never asked for. That may be the deepest lesson in all of this. The universe is not strange because it is chaotic nonsense. It is strange because lawful physics is capable of producing worlds far more varied than our first example suggested. And that brings us back to Earth. It is tempting to hear all of this and think the takeaway is that Earth is ordinary and everything else is exotic. But the more honest version may be almost the reverse. Earth is normal to us because we began here. That is not the same thing as being normal to the universe. What feels default to us may simply be what feels familiar. A calm blue planet with liquid oceans, moderate temperatures, one sun, and billions of years of relative stability is not the definition of a planet. It is one outcome, a beautiful one, a rare feeling one, maybe even a misleading one if you treat it as the baseline for everything else. So maybe that is the real shift exoplanets force on us. Not just that there are weird worlds out there, not just that some of them are beautiful or hostile or absurd, but that the word planet itself gets bigger the farther you go. Big enough to include orphan worlds wandering in darkness. Big enough to include skies where metal may condense like weather. Big enough to include planets hotter than stars. Big enough to include worlds that are actively falling apart while we watch. And once you see that, the old textbook picture does not exactly become wrong. It just becomes what it always was. A local example, not the rulebook. And that may be the most humbling part of all. The universe did not build planets around what feels intuitive to us. It built them around physics. And physics, it turns out, has a much stranger imagination than we do.